betterment of the society. So, as you have already introduced about myself, but I would also like to introduce about Subud Foundation. We are an NGO who is working into the AI, machine learning, IoT domain, and we are focusing on solving social good problems. And one of the problems that we are going to talk today is about farm monitoring project that we are working, and this is a part of such call project that we are working, and whole of the team at Subud Foundation is working. Now, Subud Foundation is a platform where we connect different dots, like giving training to the students from the institute, adopting them early. Adoption means we go to institutes, and from there we set up a center of excellence, and we basically start training the students when they are studying by providing them part-time education. And once they are in their third year or final year, once they are prepared, they are put onto the projects directly, and they are working with mentors from Subud Foundation. We have a strong team of data scientists, and our parent company is Raster Data. So we as a team work on different projects particularly, and provide training as well as environment, not only for the undergraduate students, but all those who are, want to pursue their research, particularly master students, so master thesis students and PhDs. And we also ask and request the faculty members to come forward and join Subud Foundation for solving social good problems. So that's all about Subud Foundation, and I will start with one of the introductory, I will say, presentation that I have created. Uh, Remote sensing and machine learning, they are now married. So they are married because of few things, and the advancements those have been done recently. With the advancements of computing power, with the advancements of algorithmic approaches, with the advancements of statistical power, and with the advancement of the availability of data. So there are so many things those come together, and they actually make one of the emerging field in the field or subfield in the field of data science is spatial data science. Not many people know about spatial data science, but yes, this is one of the emerging field, and there is a scarcity of people or the experts into this area. Like everyone considers that, okay, if I know some Python libraries, I know how to work with the data, but spatial data is always different. So I will start with some introduction about what is spatial data, and then what is satellite imagery. We try to understand that, and I will also talk about what we are doing at this moment, and we'll try as per the time if I can show you some machine learning that we can use using QGIS. So to understand and work in spatial data science, particularly, I'm considering remote sensing and other GIS analysis. And this is how we see at GIS right now is part of spatial data science. And the data is always very, very important. So whenever you have to work on a certain application, you try to collect the data, and then you perform EDA, and from there you try to sense whether we can proceed further or not, or do we need to collect more data, or the data that we have is enough. So before even going further, we need to know about what exactly the data is. We have seen the normal data is a tabular format where we have rows, and then the columns are presenting the attributes of the data. Now, in GIS, in spatial domain, the three important data structure or data types that we have is points, lines, and polygons. So this is the key data type for GIS. So whenever we have to do analysis, we will always work on one of these along with the other data which is non-spatial. So one of the difference between spatial data science and the other, the normal data science, is that the way the data, the particular geospatial or spatial information is processed is different. It is entirely different. Yes, please. Puli, you have a question? Puli, you have a question? Okay.
Sir, we will take the questions in the end. You can continue the presentation.
Yeah, somebody raised their hand, so
No issue, sir.
okay. So here we can see that the map, it is easy to understand what exactly I'm showing here, but there are three types of data sets we are showing here. One is the point of interest. This is called points data. And then we have lines, which are you can consider as roads. And the third type is polygon data, which you can consider as the administrative boundary of some particular area. So all these three data types are being shown here together, but these are different data sets. And whenever we are processing, we will consider them different. If we have, that would depend upon the type of the analysis we are doing. Now, when we talk about data types in spatial, we have particularly what I have discussed is a vector data. So vector data, you could consider it as an array of information, array of lat longs. And whereas we have another type of data that we will be talking about is a raster data. So raster data you could consider as a satellite imagery. So the picture that is taken, so the snapshot of the piece of the earth that you see is basically a raster data. Obviously, there is a format to it. There is a information attached to it. But on a very high level, we will be dealing with the two types of data, vector data and raster data. So it depends upon what type of algorithms we wanted to apply on. We may be choosing one type of data, and we may be choosing another type of data depending upon the application. For example, like if I'm building a routing application, then I will be preferring vector type of data. Whereas if I'm doing some farm monitoring analysis, then I will try to use raster data along with some vector type of data also. So here is the distinction between these two, and the raster type data is more like where we have cells, and these cells are called resolution of that image. In a mobile phone, when we take a picture, so one picture is made up of pixels; those are called cells, and the resolution at which we can define that cell becomes the value for that particular image. So for the satellite data, we may having 30 minutes resolution, 10 minutes resolution, 10 meters resolution, 30 meters resolution, and 3 meter resolution. So there are different resolutions, those are available. But what it says, lower that value is, it means that we are able to precisely identify any object that is within three meters. So you could consider as a cell size of 3 meter. Now, there you might have seen such images when you open Google Map, and they have a satellite visualization, and there you might have seen such maps. Now, along with the geospatial information, the raster data also comes with attribute data, and those attributes are non-spatial, but it is more like representing the information. So whenever we do apply AI ML onto this type of data, we certainly look at these attributes. So location is one aspect. The other aspects are attributes also. Based on location, we look at the attributes, because there is one law of GIS that everything nearby is more interrelated as compared to something which is far away. So that's Tobler's law. And that is basically with something in nearby, in my neighborhood. Like if I have to predict the housing prices, then something which is the neighbor's house price will affect my house price also. So if that house price rises, my house price will also rise. And whereas if some house in other city whose value is not rising would not be impacting my house price. So there is a connection between different types of attributes which we are looking at. But yes, the spatial aspect is very important in spatial data science. So for all the analysis, we need to work on the data set. So the data set we are getting from satellites. So there are many satellites out there which are providing us the information, and which are available in the domain, public domain right now. We can start using that data if we are interested, and it is nowadays it is an area where researchers, not only from civil engineering but from computer science, those are working in this area big, because this area is now a big data problem. So there's a lot of data that is coming, from different sources, and there are many companies who are offering premium services which offers the geographical data about a particular space on this earth. Let us suppose, for example, I have to look for a place, or for where I can open a new Starbucks restaurant. So that is kind of a suitability analysis. When we have to do suitability analysis, we have to look at the geographic features. And along with that, we have to look at the demographic information. So there are many types of data sets. Those will be coming together to process it. Now, one of the thing that I'm going to talk here is the satellite data. So satellite data is which captures, it's a camera on a satellite which captures different bands, and based on bands, it takes those pictures and send back. So there is a spectrum. I will not go into detailed discussion, but quickly go over what exactly the satellite is capturing. So there are bands, and each band is of value to us. So we would like to see certain features. We would like to analyze certain features of the data, and those informations will be provided by these bands. So here you can see different bands. These numbers you could consider as the bands that the satellite will be using to capture the information on an earth. So basically you could consider the light reflected from earth is captured by the satellite, and it captures, there are sensors which are capturing different wavelengths, and each sensor would have their own band they're working in. So they will be capturing certain wavelength of the reflected light, and that would be recorded. So here are some bands, those are available. Landsat 8 is having 11 bands, then Sentinel 2 is having 12 bands. So each satellite would have some certain bands, and it depends upon how much how much band it can capture, and based on the information or the band that information has been captured, we can perform a various analysis to look at the conditions on the earth. Okay, so we may not be using all the bands, but we will be using some of the bands for doing certain analysis. So here's one example of the satellite imagery, but this has been created based on different bands. It's not the way satellite looks at Earth. It is basically combined from different bands together to make it red, green, and blue. So here is one example. Your band, how this band will be able to see. Uh, so this is band 1, which is used for coastal analysis, which will illuminate the water. And then we have band blue, band green, band red, band 5 infrared band. And based on 4, 3, and 2. So based on these 3 bands, this information, this image is created. Now, once this image is created, this image is able to, like, we can feed this image to a computer vision program. So because there are many improvements, there's a lot of improvement that has been done in computer vision. So this image could be easily fed to the computer vision algorithm, and the further analysis could become similar to what we do on for other application. And that's where the spatial domain meets the normal data science algorithm. So this is, and both are now working side by side, and there is a lot of analysis that is being done and a lot of information that has been captured. So these are other few bands. There are different organizations whose work is just to clear up this whole imagery to process it so that we will move further. So these are different bands and certain satellites. So one is Sentinel-1, Sentinel-2. There are different data as now different satellites or organizations whosoever are operating those satellites, they are offering the data in the domain. So this is active sensor. Rather than waiting for the light to be reflected back, it sends its own band and then look for what is reflected back from the earth. So different satellites, they have different bands of operation. So for example, this image looks okay to us. There's nothing which is problematic. But when we do analysis using different bands, so this band is basically, we have come up with some index. Now index is the algebraic calculation or formula based calculations on the illumination of or the reflectance of different bands. So we will talk about that also. So here the combination of bands that allowed us to look at a particular concentration. So it helped us to look at NO2 concentration in a particular area. So this white area is basically representing that there is a high concentration of NO2, and that is because there is a plant for such cement plant, which generates such a huge NO2. So from that, we can basically, the thing is, rather than going and looking at, doing analysis by going to different places, satellites help us to do analysis much faster at higher level of precision. Now, there are different levels of processing. The data which we are showing is not the one that will be as is available. So there are different types of processing that we need to perform. Uh, so one of the example here is we can say that there is a point which is reflecting some value this much, but we are not sure what does it mean. So normally it is processed and normalized, and this normalization will bring in, okay, illumination, all the bands have been converted into a range from 0 to 1. And this we also use in other data science projects also, when we have to scale our data set so that algorithms can actually work perfectly. So the similar thing is also done. And this is L1, top of atmosphere reflectance. So that has been normalized to give it more meaningful value. So here are different parameters that we are looking at. Now there are different resolutions. Those are related to this satellite data. So how much does each pixel measures on the ground? So what is the size of the cell? So how it is basically resembles to the ground truth. So higher the resolution means better, the smaller will be the difference, that the smaller will be the pixel size. And then the temporal resolution, how quickly the satellite is taking pictures or updated pictures of the Earth. So those are some things. Now here there is analysis on soil moisture anomaly that has been done based on satellite data, just running one algorithm, and we will get this. From there we can identify the anomalies in the soil moisture. So something because it's a very high level based on the image. Now this resolution is very low, so we can consider that one cell is around 30 kilometers of area. It depends upon what type of analysis we are doing, but even if it is able to tell us, okay, this particular area or the strip of 30 kilometers has affected soil, or which requires maintenance, then certainly that area or district or whatever village can be notified to work on their soil. So so it depends what type of analysis we wanted to do. So here is a night time radiance, and we can analyze the earth and the light illumination at night. So there are different data sets, like we can see here, we have available MODIS data, which is having a resolution of 250 meters to 500 meters. Then we have Landsat 8 data, which is having 30 meters of resolution. Where now we have Sentinel-2, which is 10 meters resolution. We are also working with PlanetScope, which is offering us 3 meters of resolution, which is high resolution for doing analysis. Now, if we want to use that satellite imagery for our, because the cell size, the pixel size would be small, we can obviously go to the farmer level. And now, so at Subodh, we are working with two data sets. One is the Sentinel-2 data set, and other is a PlanetScope data set that those we are using for farm monitoring application. So temporal resolution is very high. So I say why we are basically selecting Sentinel-2, because it offers 10 days of updation to the data. This will be not of much use here for us. And let me show you what we are doing at Subud Foundation. So here is our project called Sashri. This project is, we have applied for funding also for this project. And the objective here is to help farmer, because we have seen there are, the farmers, for farmer, their land is their mother, and they want to save that land. Now they use the land for the agriculture. Now, because uh, we want we want that they should be actually using that effectively, whatever they are producing, and we want to utilize AI, machine learning, data science, IoT technologies for modernizing these activities, and also providing more profit to the farmers. So that is one of the goal, the project that we are working on. So we wanted to improve crop productivity. We want to monitor the soil health, weed management, detecting crop disease, monitoring crop health, water management, price realization, organized data for farmers by IoT, insect classification, supply chain efficiency. So particularly, we are creating a mobile application which is powered by different technologies, and particularly AI engine that will be helping the farmers to take right decisions. So whenever we talk about AI, it is all about taking right decisions. So based on different parameters, we will suggest the farmer to take right decision at right time. And one of the thing that I will be showing you how we are calculating one of the index is to monitor the crop health. And the approach is basically we collect data not only from satellites, we also collect data from using drones. So now we have discussed about two data sets. The drone data is the third data that we include in our analysis. So when we have a very high resolution imagery available, then we can easily identify and where the weed is, and we can actually help the farmer to just doing analysis, one snapshot of the data, and we will be able to tell the farmer where in his or her farm the repair is required. And when the actual somebody needs to spray, because I'm from Punjab and I know that how does it work, like we spray so much of urea and all that stuff. So the farmer usually they don't go to the land, so they have their own series, what we call. So they tell them, okay, this much of urea you have to use, so or the spray you have to use. So but somebody else, when they are doing, they are actually using a larger amount, so that it is effective. So the information that is processed, the government is sending some parameters, okay, this much should be used. Then the shopkeeper, because they are selling more, they ask the farmer to spray more, because there are promotions attached with each and every from the company. So they ask them to spray more, and then the farmer further ask other people to spray, and they spray more because they want to get rid of the work. So that actually created such a huge problem for the water. Now what we want is, if we are able to tell from the image analysis that what percentage of the spray is required, that is one of our motive. So there are different technologies that we are using right now, and particularly IoT is used for soil monitoring. Then we are using deep learning and machine learning algorithms to identify diseases, identifying the type of crop, distinguishing between the different plants in the field. And we also use GIS fundamentals to look at the area. If you see here, some area is being shown, and this is a Ndvi index that we will be calculating shortly. So there is a lot of work that we are doing right now, and there are different technologies that we are working on. So let me show one of the example that we are doing and working with one of NGO. So this is one of the example that we have built this platform, and we are contributing this to the society. This platform has developed one of the feature that I'm going to talk about today, and there are other features which we are going to add soon, and it will be launched to the public soon. We are gathering some data. So what we are exactly doing is this portal allows the user, particularly there is an organization called EcoSec. They plant the forest, so they are basically helping Mother Nature to, bring back those forests. So they use a Japanese technique to plant the forest. And they came to us that they wanted to analyze the impact of that farm. And also they want to monitor the health of that farm remotely. So let us suppose this, they have, planted a particular forest at particular point. So we are providing them the portal where they can actually add in those. They can geolocate their farm, so they can easily search it out, and they can easily point it. And once they point it, they can utilize this for the analysis. Let me show you here. We can give the dates. So let us suppose we give the date till today. We submit it, and it will take 1 or 2 minutes to actually load the data. So here is our data. So we can see from here, we can see we have one snapshot. Only during that duration, we have only one snapshot of that area. So that snapshot here is, you can see that it is showing the index is pretty much green. So let me show you something else here. Just 1 minute. So it depends upon the how much we have taken as a calculation. Yeah, so here it is. So there it is. Now we can see here the basically we mapped that data, and we can see the index. The green area is the one that is good, healthy area, and other area where as it is getting red, it is area which requires what I say is repair, or we need to take care of this particular part. So this is Ndvi index that we use to monitor the health of the crop. So from this, the farmer can easily, look at, what is the status. So whatever snapshot we have taken right now, this is not for the whole time. The snapshot we have taken, and only then this data is only for the last 3-4 days, and from based on that we have predicted it. Now we also will be plotting, that farmers can actually select a range of the date, and from there they can see how that the health of the farm is going up and down. So this is one of the thing that we are already working. And for ecosec, they yeah, because they are planting at different locations, So they need not to go to that particular site. They can basically look at the health of their forest from the satellite, and based on that they can actually take action. So this is one of the thing. And we are also working on identification of the height of the forest, what is the height, and then we will also be monitoring the impact of this forest onto the environment, how much CO2 reduction has been done by this particular forest. So we use a stack of technologies for this whole analysis. And let me show you one of the thing that we do is QGIS, which is kind of very leading GIS software, and it has powerful features or toolboxes that we can utilize for further analysis. If somebody wants to do such analysis on a particular point of interest or particular area, they can easily use QGIS. Certainly, they would require the satellite data. Now here the satellite data that I have, I'm showing you guys here this image. This is again created from different bands. So bands are joined together. So if I point here, you can see this image has 12 bands. So based on each and every band will have different values. So you can see the values for the bands are changing, and we have combined 12 bands together to form this image. But you could have separate band information, and based on the analysis that you want to perform, you can utilize these bands. For example, here I want to calculate the Ndvi index for this particular image. What I need to do is I need to go to the toolbox. I will select, look for raster calculator, and in raster calculator I will give the expression. Now expression is we haven't talked about the band NIR. So Ndvi index requires to work on two bands. One is NIR band, another is red band. So in Sentinel-2, NIR band is band 8, and where we have to perform this expression that help us to calculate the index Ndvi. So this is the minus between these two, and the other one is the plus. So that's the formula, basically NIR minus red divided by NIR plus red. And once we complete it, we can write down, okay, it is already there. And so if we want to give anything other than that, so we haven't talked about CRS, so that I will discuss some other time. Let's say save to temporary, and okay, so CRS is not selected. Sorry, extent is also there. Okay, here it is. Okay, so now here we can see that this is the processed image. Now what we have given, based on that, the processed image is there, and this is showing us the Ndvi that we have calculated. And I can use symbology available in QGIS that would help us to basically look at the image. So let us suppose I'm here, I classify this, and now the index, the Ndvi has been classified. Different classes have been created, And based on that, we can look at what value. This is minus index, which is showing this is not vegetation. And as we are growing, this is something which is, a vegetation. So this is helping us to look at the vegetation index. And that's how the script basically running at the back end that we are implementing, and that is projecting the onto the web browser. So basically, what we have done right now is we developed a analytical engine that takes the from the farmer the information about where is their farm. They will map that farm, and that request will go to our server. From the server, we will look into whether it is a valid request or not, and based on the request and the data, we will try to fetch the data from Sentinel-2 or other sources. And once the data is fetched, we have scripts. Those are working on the data and provide back us the processed image. So we are basically, it's a complete package of how the map renderings, how the analysis is being done. So there are many parts which we have already completed. So data engineering parts where we are collecting data from different sources, and then ML part will be used for the classification. So one of the example of classification, just I would like to show you if I have time. I'm not taking, do I have time?
Yes, sir.
Okay. So one of the example here is how we can apply random forest algorithm. We hear about that it is one of the very promising algorithm, and here we are going to use random forest for classification. So let me show you. I've already tried these analysis so that if something is not working, I can actually show you. So this is the original image that we were seeing. Now let me show you how I play with the bands. So these are the bands; those are there. Okay. Um, if I have to present it in a true composite format, so it's 4, 3, and 2. So when I give this information to the renderer, it basically showing me the actual image. I hope some of you already know this thing, hopefully because you are related to agriculture, so you must be knowing that when we are placing uh, a band appropriately to the computer band, and it is basically helping us to look at the type of the image. So that is one of the thing that we can always change. This is very flexible in QGIS. You can always look at different aspects, and based on even looking at different bands, you can have a visual inspection of the area that you want to analyze. So once we done, this will have some certain attributes. And along with this, let me open this. It's not working right now. Anyways, so here next is the data that has been taken as an validator. So this is the training data. So training data is the pieces that we have collected from the ground truth, and these pieces are actually would be helping us to do the classification of the area that we are looking at. Then we have similarly the validation data. This is very, very small. Here it is. So this is the validation data. This is the test data. So that has been already collected. And this is the raw picture that we will be classifying. So for this classification, QGIS uses a toolbox called OTB. So this OTB toolbox is uh, very well known. And I'm right now here. It's not like, let me restart this. Just give me 1 second. Meanwhile, if there is any question, you can ask. Meanwhile, I'm starting. So the objective that I want to show you is that we can apply ML for the analysis of any type of the spatial data, particularly and the satellite data, and this is how we are doing. So let me, yes. So OTB has a algorithm which is already developed, and that algorithm is first we will see a train image classifier. This image classifier will take the parameters like what is an image, what is the training data, and then we also look at what is the validation data. So once that is given and other parameters are given, this will help us to basically build the model. So it will help us to train the model. So once the model is trained, we need to then, we are giving here the same image, but here we can classify any of them. We can you give a different image, and then we can select a model. So the model is saved as a text file. So let me see if I can fetch it. So here is the model basically. So it is saved as in a text file. I fetched that RF model, which is trained model, and pass this to this processing toolbox. And once I click it, this will create image like this. So the processed image will be presented to us. Now, this does not make sense right now, but what we need to do is we have to go to symbology. We have to click classify, and we can see that there are 3 classes that those have been created. Now you could see that it has uniquely identified the water, the vegetation, and other suburb area which is in the image. So this is the true image. So this is the true image. Now let me change this also to the correct composite. So here is 3, 4, 3, and 2. So here is the correct image. So this is the river. And if we see in the classified, we can see that this river has been correctly identified, although there are false classes, but it has done a lot of good work here by the algorithm. So we can try and test different algorithms and apply those algorithms onto the data. So we what we did is we basically start from QGIS, we build our algorithms, and once the algorithms are built, we posted those algorithms to the production pipeline, and those algorithms are working for us. So we will be launching the app soon, which is SSA for the farmer, and that will come to the public domain where any farmer from anywhere in the world can actually use it. So that's all from my side right now. If you have any questions, you can ask. Obviously, there is a lot of work that we can, many things we can discuss on. So here are different like NDVI, then we have water index, then we have built up index. So all these indexes are basically highlighting a particular area of interest. So we have bands, and using these formulae, so this is the formula for NDVI. So we applied that, and we could see that we were able to identify the vegetation. So similarly, other indexes can be formed, and those indexes will help us to identify and analyze the area of interest. So that's all from my side. And the data set is available in the public domain. Particularly, Google Earth is doing very big. There are people who are working a lot on Google Earth Engine. ArcGIS has also coming up in the area of deep learning and image analysis. They have also released their repositories. Then QGIS is the third one, which is there, and it is an open source project. It do have the ML, algorithm, but it provides us a flexibility to enhance those products and contribute the implementation to the society. So there are, few things. One is learning the technology that we are doing. Another is using that technology to solve the problems. That's all from my side. Thank you so much. And yeah, over to you, Diksha.
Yeah, thank you so much, sir. Now we'll have a brief questionnaire session. I'll be reading out some of the questions. So first question.
Yeah.
So the first question, contribution of geospatial data in overcoming the various problems of agriculture.
So we have discussed that we could utilize the two types of data sets. Those are available. One is helping, like the SSA product, which we are building, is particularly dedicated to agriculture farming. So I think that we have already discussed, but certainly there is a lot we can do. Particularly the part that I have emphasized is how we can utilize the satellite data and along obviously the technology to solve the problem of farmers. And we will be using mobile application because each and every farmer use that mobile. We will be bringing all this technology at a very high level. High level means the farmer need not to know about what exactly the intricacies of the product, but they will be able to utilize this for monitoring the health of their farms.
Okay, sir. So future opportunities in geospatial data for agriculture.
There is a lot that can be done, and certainly there are different indexes, and there we need, because earlier the geospatial data or the satellite data was being used by the governments to look at different parts of particularly if I say on states, and look at weather forecasting and all that stuff. But nowadays we are going very fine level because of the availability of the type of data sets and the availability of the computation which is available to public. Like, we are having the infrastructure which is including GPUs and all that, the computer infrastructure. We have the talent, and we are building that product, and that's how we will be solving the social problem for farmers.
Okay, sir. So is there any device developed by a company for farmers which helps to record all the meteorological data?
So there is our IoT branch. So IoT branch has developed a few circuitries or the sensor devices that is used to monitor the soil. And we also have developed one of the circuitry to record bird sound, and that bird sound will be used to identify, like I was talking about one of the project EcoSick, where we are basically recording the bird voices and look at how many birds are coming to that forest. So it's kind of, because birds are the ones which are very much affected by the environment change. So we have set of devices. Those are we are building for farmers as well as other organizations.
Okay, sir. So next question. Can we detect plant disease and insect infestation at early stages with the help of remote sensing?
So we for that it is dependent upon the quality of the image. So if the resolution is high, certainly we could. But what we are doing is we are using the mobile camera and asking the farmer to basically take a picture, and from there we will be able to identify on a high level, like on a field level, we will be able to for sure tell them that there is a particular disease and affected area in their farm.
Okay, sir.
Yeah.
So next question. How this technology will be beneficial to small and marginal farmers, as most of Indian farmers are like small and small scale farmers?
Yeah. So because this whatever we are doing is for social good, and this application will be available free of use to the farmers. This would not require any substantial amount. So first of all, they need not to spend any money on this analysis. They just need to register and install our app, and rest of the help would be automatically done by us. So we are basically powering up ourselves or preparing ourselves so that we can work big and provide actually the infrastructure for all the farmers. Particularly, we know that the small scale farmers, they have so many problems in Punjab. There was so many suicidal things. So we will be trying to implement that. That is one part that we are also working, is to identifying doing the speech analysis, and based on speech analysis we will be trying to identifying the suicidal thoughts if somebody is having. So kind of it's an app that we are building, is a complete package for the farmer.
Okay, sir. So that was the end of questionnaire session. Thank you so much, sir, for joining with us and for giving your precious time to us. It was a lovely session, which was very interesting as well as informative. So thank you so much, sir.
Thank you so much. Thank you, Just Agriculture and the admin for calling me here. And it will be great to work with you guys for future projects and involvements. Certainly, we are looking big, and we want to become the backbone, the IT backbone for all the NGOs and the organizations. Those are working for the farmers and other solving other social problems in Punjab and in India. Thank you so much.
Thank you so much, sir.
Bye.
So the first session is over. Now I'll welcome the second guest for today, Dr. Said Ismail. Are you there, sir?
Yes,
Yes, sir. Good evening, sir.
good evening.
Uh, So now I'll move on with our next session of today. I warmly welcome our guest of honor, Dr. Syed Ismail. A brief introduction about Sir. Sir is the director of SIFA Sunpra Systems Private Limited, and he is also a consultant in NABARD Consultancy Services, Mumbai. Sir is an agriculture engineering and management professional working in embedded electronics related to agriculture, automobile, and process control industry for the past 40 years. Sir has also made many publications related to it. Sir has given lectures in various webinars, workshops, and highly renowned institutions like the National Academy of Agriculture Science, IIT Indore, ISAE conventions, TNAU, etc. Sir was also present with us for our previous event, that is Agriculture 2.0. It is an honor to have you back, sir. So without any further delay, I would like sir to start the session.
Thank you.
Thank you.
Good evening, everyone. Actually, today I'm going to tell you about the most important thing that what the country needs now. And we must have heard about the dangers to the environment and all the problems we have. But we also know some problems we were having for the last 30, 40 years, and we have been not correcting it in time. So let me put the interesting subject of IoT, which I'll explain about IoT and a bit on how to implement IoT. What are the requirements in agriculture, Indian agriculture today, compared to, because there are a lot of cases of even Australian agriculture, they tried IoT, what problems they have. And I think India, what it faces right now, and what will be the problems in the future in IoT, and why we need IoT in agriculture. And plus also I'll take an example of one of the benefits that IoT can bring to Indian farmers. The previous speaker talked about excellent about GIS and the mapping and working with the farmers and helping in the identification of insects and whatever pest diseases. It's an excellent approach. It's everybody. Last 7, 8 years, only in India, this trust has come, and probably 5 years or so, also in the world, throughout the world is working on the latest technology. So let us see a little bit about it. It'll be more of a talk for you to understand the concepts. I'm not going to talk about, I'm not going to teach you electronics. I'm not going to teach you something that I can tell you where to read it. And we also have different webinars I conducted on that. But I'm going to give a concept, basic concepts to you. So you will understand, I think, the students as well as others, where reality, where you have to work for first in the technology to come, especially IoT, where how it can help, and how difficult it is for anyone to make, and how expensive it's going to be. So IoT is a things which are spread out, not necessarily web-oriented things. Okay, it's a devices connected together. That's called the IoT. We'll come to successful application IoT in India. It's not the 7 years only India we are having IoT. We have 20 years, 25 years. I recall we have IoT. Normally, we don't recall what is IoT. I will tell you metering application. I recall somewhere in end of 1995 to 2000, in Mumbai, most of the industrial area, metering was done by a GSM that was starting in early 2000. And water meter reading in most of the Mumbai part and Pune, they're already by remote. Nobody comes to take the water meter reading in your society. Nobody comes to take electrical meter reading in your industry area. So this is actually an IoT, which means the information that, because the metering, the companies, electrical service providers, they had problems of approaching each one. So we know this IoT is a good example we already have. This is how we would look for the applications, what we are going to have in agriculture also. You see, AMR, I mean, automatic meter reading, has got a lot of components now. Now it has become widespread throughout India. And I know about 7, 8 years back case in Delhi. I mean, some big companies asked, they want to disconnect the electricity power for industry from the pole itself. So a lot of work is happening. This is a very extensive networking IoT application, which we are not aware of it. But these are all need-based. They came because people wanted it. They can save some money, they can do. Now we come back to industrial application of IoT is in India for a very long time. You have already most of the PLC machines are connected. And I remember making mold emissions before 20 years, which has since, 18 years, 15 years, around sending SMS. So you know the status of how many PET bottles have come out. So these are all existing. Inventory management, we are using already extensively. Packaging, everything, logistics. You read, you name it, almost we are using industry, but it's not in agriculture. Agriculture just now trying to start. So we'll see the reasons why and how to speed up and what is required. So industrial, when you go, much more is there. And there are a lot of companies working for industrial IoT. A lot of companies. You see Amazon in warehousing. They specialize on one part of the industrial application requirements. Where similarly in India also we require, agriculture is a huge field. If you know, that is one field that you look at all Panch Mahabhut as well as whatever comes outside, the farmer has to make some sense and some money out of it. So it is very important that we have several companies coming in different aspects of the IoT applications. Now, we also have an IoT innovation in the last decade in India. The need was rural electric supply available only in the night. For example, even Punjab, I think it's in the night because of the reason of dry leaves rubbing against. Most of the near towns they give because cities consume more power. So nighttime they give for the water pumping. So now, if you see it now, here the limitation is limited cost. So we have already given in the last, let us say, 10, 15 years, I see many places in Maharashtra, other places, you have automatic SMS-based pump controller. Now, when you go for IoT or agricultural applications, we have to look at the important fact of hype we can create. Like we've been talking about a lot of technology we'll be talking about, and these are all excellent looks in the beginning. This I showed in the last one for precision agriculture. For IoT also, you can look big data here, for example. This is a peak of expectation. So it's about 4 years, 5 years, you go through the line. 20 here is about 5 years line is given. And ultimately, when you get the enlightenment, only few of what you thought and worked on it will be successful. And India is a country which doesn't have so much money to spend on it, and neither the farmers have. So we have to try to find out in this zone itself, right now, with all the wisdom we have, how whether it is feasible or not. Now, there's one more thing when you go for any technology, innovations will create the technology. So there is a difference between innovation and what is invention. Okay. Innovation, you have to know existing process, then only you can do innovation. For example, a guy want to do for agriculture some innovation, he must know about agriculture. He cannot sit in a computer room and design for agriculture. It's very difficult. Today it's trying to do people. That's how you find a lot of drone companies started before 7 years, where they are or what profits they make, when they will make. So one of the problems is the combination is not there. Conducive facilities, knowledge source environment, acceptability and affordability will be the market. The market must be able to pay for the technology. See, we need a pull-based technology. Then farmers need it. Now, Indian agriculture, we already had innovations in last 60 years, the green revolution. So we had, for example, choppers, threshers in mechanization, dusters, sprayers. We brought it. Dusters came only during that time. The drip irrigation brought it. We brought sprinkler irrigation. We brought combine harvesters. And we also have GMCs. So these are all already innovations we brought into the agriculture. Now, what are the emerging technology we are talking now is, we know everybody knows about it, and a big hype is going on. I'm sure some of the applications are excellent, but some of them are very hype. Like I know at least hundreds of people who ask me, sir, Python, if I learn, I will get artificial intelligence or what? So I have to explain him what the hell is expert system or artificial intelligence. It doesn't come from a language. You need a lot of layers of information there. So the basic problem, the thrust today is like a olden days when the computer science came. I think if you know the computer, so very the old people know about CPM and all different systems came up. It was always thrust on certain things with the new terminologies. So we have to be careful on to select for the Indian agriculture, which is adoptable. Let us say within 5 years. Many business cannot run for 20 years of investment in India. It's not possible. Big data and agriculture, people talk about. Yes, they are applicable very good in godowns, warehousing, logistics, excellent. But that doesn't come to the farmer level directly. Now, virtual augmented reality is excellent. For example, somebody was talking about they want to find out insects, pest attack in advance. I think one point I see, we know farmers know the pest attack only in the second time. That means after 15 days, the first attack has come. Nobody can identify the first time the attack. One company, I think was from Canada, was trying to demonstrate about 3-4 years back in the CAST program. And they were trying to show virtual reality, but it's not ready still, the information. Nanotechnology has a very great scope. Now they're coming. Robots, drones, these are all the new technology we know. Now we come back to actually the current status. I'll go quick about what is the current status, because we talk about technology. Let us know the reality today, what it is in India. Then we give the examples and come back. See, disparate the agri and non-agriculture employment disparity is very high. A professor gets salary of 2.5 lakhs, whereas a farmer earns only 2,500 to 6,000 per acre per month. Not per household, I'm talking per acre per month. So if you see it, a person of corporate staff or whatever employee, a peon gets 60,000 rupees. A farmer to get, he needs at least 10 acres in Punjab to make that money. So that's a problem. 50% of population on related activities, and 85% farmers are small marginal farmers. And one more problem here is we produce 20 to 30% of wheat, rice, and sugar, and we can't export all of them. Luckily, last year we exported a lot of wheat to nearby countries. Still, we have a problem to export some of them to certain countries because of our chemical content or taste, whatever may be. We have actual less value, nutritional value of the. We produce enough fruits and vegetables also. Still, we have nutrition problem because they don't reach the correct people. Now we import a lot of vegetable oil. I mean, if you see today's newspaper also, our exports have gone up and imports also has gone up in agriculture, very high. So because oil we import, because we stopped growing sunflower, we stopped growing everything, only concentrate on soybean. And it's a cash crop. And I think we will not go into details of this. 2 years of chemicals, we come back to the current scenario of farming. We know the poor coordination from farmer and research institutions. It's 100% true what I'm saying. If you go, nobody has, for example, what about products manufactured in India, who supplies it? There is no database. There is absolutely nothing available if you look for it. Really, we have hundreds and hundreds of institutions, universities. They do multiply the research, reinvent the wheel again and again. So this has to be done. Now, another problem in the technology side, 85% tractors we use, 15% only equipment. This is compared to other countries, it's reverse. So we are tractorization actually. We have to come back to actually to use the productive output in farming. And of course, subsidy has not given the business. Rural employment is not there other than agriculture. There are no skill development. Actually, that's the basic problem we have now. And let us come back to the need today, what they need. So why I'm telling this, now only we come to IoT, what is important, what is the importance right now, the next 5 years, what we have to concentrate first. Soybean harvest is a need because loss of almost 20 to 30%. Cotton harvest is not existing till now. I mean, sure, you can ask, go and see. Crop rotation is not being done, and reduction in pre-harvest losses. We don't have. We harvesting losses in, for example, 50 to 60% in vegetable fruits and vegetables from farm to fork, what we call. It's a really high. So there, IoT has to help. What I'm saying, your technology must help there to reduce the losses. And we have high dependency of chemicals. I think about 15 days back, the government again has to double the subsidy for another 30,000 crores for some of the fertilizers cost to cover it up. So no storage facilities for short time. So for example, banana reaches every place, but not in other fruits. And we have no value-added agro-processing. We don't do it. There IoT is very much important. Now, current needs. Actually, when you see, I will have 1 minute on this topic. Conservation agriculture is very important. India has been doing for 10 years research, but nobody has come out. Last year, I tried to run a webinar series, complete international speakers on the conservation agriculture, where we need IoT, where we need technology, which we don't have. The conservation agriculture, I'll explain in the next slide. Then we have a climate resilient agriculture that many of the state departments are working very hard. There are problems, but they understand the problems now than it was used to be before. Urban agriculture now became popular. That's one of the, because you cannot transport fruits and vegetables. There is no sense in transporting them for 300 kilometers. So it should be an export market. It's very huge. So urban agriculture, or we call that, is the one thing which will really need. Reduction in water, and we'll come back to the detail afterwards. agro-processing. So these are current needs. Now we come back to certain things further. I will skip this very fast because these are all what is innovations to come. But IoT is an innovation. You have all innovations to come. We are missing a lot of points, and basically it's a coordination between the different stakeholders. And generally, all these things talks about only that. Then, for example, we have like domain. Today, we find a lot of people sitting and doing work on the other domain. Everybody jumps into agriculture domain. I wanted something. He does not know what is plant pathology. He does not know agronomy. So he does not know how much water requires. What is the plant? Only IT cannot grow agriculture crop. You need the idea about it. So you need, see, there are two possibilities. Everybody cannot learn all the domains, but there must be interaction between these two people, or the IT domain people must learn a little bit of agriculture, and agriculture people also must know the limits of IT domain. The second part is missing completely. When you talk to agriculture experts, they know nothing about IT to the extent they should know to incorporate the technology. This is what we will talk about for about 10 minutes today. And another hype is coming in the agriculture sector is the IP rights. You make thousands of patents. If you ask, I talk to professor from anywhere, I see anywhere, there are a lot of patents. What is the use of the patents? Because they get credit marks. That's wrong. Actually, we have to make the young scientists, young students to look for creating something useful first. If it is useful, then look for patenting. Just patent means it doesn't mean it works. Okay, this is a misconception. Sir, he has got 5 patents. He's not great. He's probably useless guy because he cannot even bring one out useful to the public. So to product to come out to the public, there are a lot of requirement is there. Because I touch the conservation agriculture, I promote conservation agriculture. It's very simple. You have to maintain a permanent soil cover. You cannot leave the soil barren because water will evaporate. Okay, well, not only water, many more things will happen to soil. Minimum soil disturbance, because most of our hard span of rice paddy fields are damaged. Okay, no need for using heavy tractors, plowing, not required. Not required. It's proven everywhere. Not today, it's proven for a long time. So listen to the following. Minimum soil disturbance you give and diversify the plants. Don't grow monoculture. The biggest problem also Punjab, we have Haryana province monoculture, and PAU has taken last year itself steps for the next 5 years to change this completely. That's welcome. Next one, we have to look at IoT and in agriculture is if food security is a big issue will come now. I'm foreseeing 5 years. What's going to happen? I'm telling you, this is the international scenario where you have the food, you print the food, veg meat, proteins. There'll be no animal farming space, grazing land will not be there in the world. So this is a hot topic in all other places. In India, seldom talked about it, but still there are some people working in India on insect farming and veg meat. So this is one area of agriculture where you can use a lot of IoT and automation. Now, this is last time I showed, but I show you, this is done before 2 years, IoT in agriculture. I put in green color what are important according to me. This is my personal discussion with few people. What is the importance? For example, you require solenoid valves and pumps. Irrigation solenoid valves not on manufactured in India. I try to find for last 5 years. They are still imported, most of them from China, US, or whatever maybe, but it's not from India. And you don't have a depth measurements of canals, water sources, warehouse management. These are all priority we require. And optional second level of priority I given for crop protection, for example. We don't have much advancement in spraying equipment and livestock. Even there, we don't have much equipment to see it. And this one, third and last one I gave the importance to is artificial intelligence, machine learning, edge computing. These are all at the final stage of it, because before it reflects the benefits to farmers, it will be a long time. It's not going to happen next year. So I don't mean against anything. I want to say some people can work on this research, R&D, everything, but some people have to work on the requirements which have urgent need in the next, let us say 2-3 years, we can bring results out, 2 years out, and within 5 years, the farmer will benefit. Now, there is one app required. There are many people, I think recently also some company launched an app which would have all the parts what I have given here. starting from weather forecast, threats, land records, crop selection, what crop my neighbors have planted, next village people have planted, so how much, so what price I will get. And this in totality, it is not available. I have presented to many people this particular one. This somebody has to work on it. Really, I can share all the slides, but it is very important to cover all the aspects of it, so it is useful. Now, come back to exactly today, one of the example of water. I'll put some facts again here about water. See, India has about 17%. This is probably 1 year old statistic, or I don't want to argue somebody with 15% or 20%, doesn't matter, of the world's population. We have only 4% of the world's freshwater resources. Okay, we don't have enough freshwater resources. And when you look at precipitation, that's a rain, 400 billion cubic meters, 48% only we use. The rest of the thing is not, it goes out in the sea or wasted. Now, this is the most dangerous stuff, groundwater depletion. See, 40% of irrigation in the world using groundwater. So I'm not saying India is using, but 50%. But you should understand, India has a maximum arable land, okay? Maximum cultivated land in the world is in India, not outside. Don't think USA is very big country, Canada is a big country. No, the arable land is India is the highest. So now, urban requirement 40% groundwater. The groundwater was accelerated by a lot of other mistakes we have done in earlier time, and we don't bother about groundwater research facilities because nobody cares about it. Even the farmers, when you visit them, before 10 years or 5 years water level, you will say 50 feet gone down now. So where the water will come? So we have to think carefully, and we are all scientists, engineers, all the people we are sitting here. But I would like to show you, there is somebody else, the farmer. This is from this year only in January. I'm telling you this. This is one B district farmer. He spent his own money, 1.5 crores. He's got 12 acres farm. 1 acre he made as a farm pond. Diameter is 202, diameter 41 feet depth. Now, the full water from I think somewhere probably January, February is the picture, and you will not have a problem for 2-3 years. Not only him, he can give it to all his village farmers, probably other people. And this costed 1.5 crore. Imagine you make tens and thousands of this type of farm ponds. How much surface water will be there, and how much billions you already waste money on other research products. What other works are done? There are projects going on like groundwater well connection, interconnection, like river connection. I think this surface catch it where it falls, and that is what the first thing. Second one, I would say, the good example to see is what IoT can come into picture. This I've been telling also this is the alternate wetting and drying. Indian farmers use a lot of water. They waste water. Everybody who knows about stuff, they waste water. We won't have water. Probably in not 10 years, probably we won't have water. And rice is 40% of global water is used for rice cultivation. And 2,500 liters of water required per kg. Now, what this is done in somewhere in South, Calcutta also a lot of work has been done. And this is a done research and well proven method that you need not irrigate rice fully with water. You can go 15 centimeters below the surface. And when it goes 15 centimeters below, then you can re-irrigate again. So you will save 30% of water straight away in this. And see, I'm not talking about rain-fed irrigated crop or paddy, but what about the eastern side? We have a lot of lifted water from river or whatever it is, the water lifting schemes. You can save electricity, and 30% of water is much. So any money farmer saves is good for him. Water is free, don't tell, but electricity also free sometimes. Problem is anyway, water we are losing. We won't get for the next season. Next work I would say is about subsurface irrigation, which is expensive now, looks like. You actually lay the pipes underneath. And some people do it subsurface pipes only, and sprinkler they use it. But we are talking about subsurface irrigation. This looks expensive in the beginning, but 10 years I know. This is from Buludiana, Bisa, Bolog Institute of South Asia. There are a lot of researches been done throughout the world. How effective is a subsurface irrigation? And actually it uses much less water and much more better, because nutrients also you put very less. Okay, we talk about natural farming afterwards, but the question, when you want to put nutrients, anyway form of it, you can reduce it because you send directly to the plant. You don't waste it. And because you don't have barren outside the soil, you don't have weeds problem. That is the interesting part of you want to grow. Now I'll come back to the example which we will spend some time on. Okay, fine. Now till now I told about farmers don't have much money to do it, and farmers are actually in distress. Rather, I would say throughout India, because the city people, we think farmers have a lot of problem. I went to the farm. I saw in my village people have bikes and all. They have pakka house now, not like before 30 years. But they forget the problem thing. They don't earn 50,000-60,000 rupees every month, like a peon in a city or somewhere. And the cost of living is not much different. And farmers don't eat that much fruits. They can't afford to. If you look at all those things, it's a huge population. And India cannot throw away the farmers. So we have to work on it. One way is to cut the cost. Okay. Another one is to sell it at a higher price. So both are possible. Inputs, either reduce it, or output ka value, but other. So output value when you want to increase, that's what export promotion, everything has to be done. We have a lot of infrastructure, government is working, all people are working now, but not in the correct fast way. It should be, but according to me, but anyway, work is going on. Input cost reduction must be done. This is concentrated by less people. Like water is one of the important things, fertilizer inputs. So now stopping fertilizer is not a solution only, because sometimes you have to use. Only question of limited application, where it is required, we have to go. That is more logical way approach today, rather than just blindly going that we'll use only natural farming without any fertilizer. You won't get that output for next several years, and we won't have, and we cannot feed it overnight. Now, irrigation scheduling, very simple irrigation scheduling. Today, I told you farmers use too much of water. However, the computers and IoT can help here. You irrigate not the soil. You want to irrigate the plant. You want to put water to the plant. You want to put the fertilizer to the plant. You don't want to put to the soil. Soil doesn't need from you. Okay, you don't disturb the soil. It will regenerate itself. Actually, whatever you put inside, as whatever the residue which is lying on the itself will regenerate soil. How much water the soil can hold is important. People put a lot of water. This happens when the heavy rain comes also. That time also, people irrigate much. So this is a real problem. And the third one is important is how much of the water is being used by the plant. So now we come back to advantages of the irrigation scheduling. It enables the crop water stress. Water is not there, it will, when you schedule correct time, the correct time is fed, the plant is fed with the water. It reduces the cost, lower fertilizer cost, increases the returns because you get a better quality, because correct time you are giving water, and there's no water logging. And salinity drainage problem is not there. You know, we are going to have severe problem in the next 15 years. Again, I'm threatening, because salinity is a big growing issue which nobody is talking about. We have several institutes, but not much work done about salinity. I'm not talking about rocks, saline soils. I'm talking about salinity induced. Like for example, sugarcane crops. I know Maharashtra, some areas, there are many land is just barren. It cannot be cultivable anymore. And we know already the Cancer Express in Bhatinda goes there. So we know the problem of all this chemicals overdoing on there. Criteria, how will I schedule the criteria for irrigation? Soil moisture depletion, plant basis, plant indices, climatological approach. From climate also will help you, and critical growth approach, which means the plants require water. For example, flowering time, they require water immediately before. Just flowering time, they need a lot of water. So it's a critical stages of the plant growth. There you have to apply. See, these are all known only to agriculture people. The other people will not read only from Google. You will not be able to do that. The Google gives some information only. So plant, what is the water content in the plant currently, the status. Now, this is based on irrigation scheduling, is based on different additional parameters you have to look, like what type of pump you have. If you are using irrigation, let us say drip irrigation, what is the rate it can deliver, and are you applying it uniformly, and how much goes really into the soil, what is the slope of your land, and what is the water capacity of your soil, how much water it can hold. Whatever you irrigate will not hold dry now. So it depends on water capacity, how much it is. Effective root depth of the plant you're growing. Depending on the crop, you have to give how much the water required. Not every crop will have so much time. I can predict from outside. Difficult. Even satellite imagery, 5 meters accuracy, what we get, or even 1 meter, we get less. But it's difficult to predict which type of crop, what. These are inputs required anyway. And plus, it's a question of, we'll come back to in detail what other technology available. Current water requirements of the plant, evapotranspiration. How much evaporates it out? Amount of time in which water is available for you. That means your well has how many hours of water to be pumped up, or you have a water pond available, how much water is available. What is allowable moisture stress? That means plant will not die if you don't give water one day. Okay. So what is the stress depending on the plant? It depends on which stage the plant is there, which stage of growth. So, and is there any rainfall projected? This is very important criteria, I think, because rainfall projected in Africa they're using effectively, because they have a small meter to show whether it's going to rain today, tomorrow, let's say in the afternoon or not. The farmers are advised not to do fertilization in the morning. So 1 bag of fertilizer saved for him, because probability is not 50%, you can get up to 70% predictions. 70% comes through with the computer modeling predictions that whether it will rain today, afternoon or not. But many states in India will not apply because we have seasonal rainfall. Now we come to water modeling. So this water requirement modeling is one of the important topics which IIT Mumbai has done. For example, find the water productivity, and this is one thing we can use immediately available. People, some of them, you normally take off rainfall, runoff, evapotranspiration, irrigation losses, how much, groundwater recharge, how much. You have to measure outside humidity, temperature, and soil color. Okay. Now, what we call is natural vegetation density index. Okay, and then infrared and normal red reflection. This is what your cameras take. Okay, there are multiple available cameras available, and our phones have only RGB cameras, so they cannot be used much more effectively for finding the vegetation, whatever information you require. But satellites have. So this is one of the what is the evapotranspiration is very important. That's the reason we say have a soil cover. If plant is not the rest of the place, don't keep it empty. Some cover must be there. So the evaporation will be less. So your water requirement will be less. Because there is no water on the top of it, the weed will be less. So sunlight, humidity, temperature, these are all very important factors. Now, this is what another one, there are Landsat, they use satellite imagery directly to compute. And there are some, I know about a company, couple of them in India are trying to do this to give advice to farmers when to irrigate, not to irrigate. But frankly speaking, I would yet meet the farmer and meet one farmer and ask him whether how effectively he's using. So this will be a shot which will be possible reality in some, not in the immediate time, but probably in the future. Now, I will try to tell you current irrigation scheduling, what we talked about. IoT can help very much in scheduling the irrigation. That means very simple it is. You have a pump. It will start particular time, stop particular time. And that, how much time it runs the pump, everything depends on so many parameters, starting from weather conditions, normal local weather conditions, and water availability, your plant growth, everything stays. And of course, you can also take soil moisture. Okay, what is the moisture, current moisture? That also we'll discuss now. So these are all different parameters you can find out, take it, and then find out how much. You see, this is an example from Kerala, somewhere I've taken. See, for example, there are different agencies. Already you have data of how much water is required to be irrigated per day. So coconut, for example, you see many of the farmers, they use less water than what is recommended even. So that shows the farmers are advanced. They're using, they're having information, they use it. So these farmers can adopt easily technology. Now, there are some many attempts have been done by the irrigation scheduler program. I see only in media and papers and everything, but I have to still see thousands of farmers using. India has millions of farmers, thousands of farmers using out of any one of the attempts done till now, because whether it is feasible, not feasible, farmer has to use it, not use it. These are all complicated issues where there is no answer comes from. Now we come back to soil moisture measurement. This is very important for you, those who want to work in irrigation. Okay, I have done quite some work on soil moisture measurement. These are matrix potential sensors. The number 6 written there. They are quite accurate. They're very expensive. And see, when you go to time domain reflection, TDR sensors, for example, like this, TDR sensors are used in cable fault finding, very good in electronic line when you go, but it's not accurate enough for. Still, there are many companies that have sold to many universities, not found the farmer can utilize this TDR right now and use it. The old, very old soil tensiometer, this is probably the most accurate, and I find many other farmers can still use it. If you can, here only, there are some attempts. I'm also trying to attempt it to make it with the wireless here. So it only measures the pressure. Only trouble with the tensiometer is water has to be poured inside, but the accuracy is very high compared to any of the other sensors available till now. A lot of work has to be done still in soil moisture, not just published papers, but we want to see it in the field of hundreds of farmers are using. For example, BISA has used this MP6. They're using still in Ludhiana, MP6, quite numbers they're using to automatically. Now, this is from somewhere in the US again. There are tensiometers and different instruments you can use it. There are nanotechnology available also that can directly measure but they're not still ripe enough to come to the field. And still there's doubtful whether it's going to be affordable by the farmers. So that is one question I have. Now, who are working for urban farming or protected cultivation, pH, oxidation, these sensors are available easily. You can use them. Now, in automation, what do you call water level measurements? We don't have. We don't have even recording of timing. Let us say in a borewell, how many hours it works. Now, these are all very easy to implement. For the borewell starts and stops, you know how much water is going. You can measure by the current, for example. And this we don't have. So we don't know the amount of water in a borewell. The farmer just pumps as much it is there. Except in Punjab, when solar panels are on, from morning 8 o'clock starts pumping till evening 5 o'clock. So that was one of the problems they had earlier times. So we have to have the sensors that can be integrated. We don't have output actuators. Like I told you, solenoid valves is one of the irrigation solenoid valves, 3-inch, 2.5-inch, huge ones. They are not manufactured in India. There's a good potential for some of the youngsters to come up to manufacture solenoid valves. Now we come to another few minutes we spent on IoT in agriculture. It's the biggest issue is the imagine I have 2-3 pumps, so I need to monitor 2-3 of them, and I want to put soil moisture 2 or 3, or I want to have drip irrigation with, let's say, submarine lines, 3-4 submarine lines I have. So I have to switch the valves. So it's a quite a big scenario when you consider 50 acres, let's say normal Punjab land or whatever it is, 50 acres size. It's a big job actually. So how to network them? This is one of the important things that agricultural people must learn about it, because there are domain experts, those who can do the networking. IT people are there. There are other guys who will do, but you must be able to explain to them exactly what is your requirement. And many a time, mismatch is the biggest problem. You waste a lot of time and it doesn't work out, and you leave the topic. So in the field, the communication is an issue. Now we come back to the form connectivity. The important is the technology. It's a very long distance, and scalability. You must have multiple devices. And there are two types of data required in agriculture: low rate data rate and high data rate. High data rate required for AML, drones, cameras, interactive robots. Many of the interactive robots don't work even in Australia because they don't have the bandwidth. So the problem is robots, excellent works, but then it needs the bandwidth. So it doesn't get the bandwidth, you don't have the tower, nothing will work there. So, but low data rate is what you have: pumps, actuators. 99% of your today's agriculture scenario can be done with a low data rate. That brings us with the excellent solution. For example, pump starter, I can put a SIM card and use it. But how I am going to use it in case if it is going to be 10, 20 devices? How will I pay the SIM card charges? So there is something called LoRa, or we call about. I will explain this. What is LoRa? Is a technology. This without confusing, I'll try to do it to you. And we all know Bluetooth, LTE is the 4G. What do you call? This all we know already. We all know the terminology. Each one has its own limitation, but you can use almost all of them for your agriculture purpose. But what is the dream actually required is to have, let us say, every few villages, you have one small tower where you have a gateway, and you have tractors, everything running with the LoRa device. LoRa is a technology, it can transmit even up to 5 kilometers. It's free of cost. So with one gateway, with LTE or connectivity, you can connect to several, maybe one village, couple of villages, depending on the village size. And you can connect thousands of devices to it. This I proposed to some of the, to some people in the top several years back, but nobody wants to touch and do it because individual, because I think this requires probably a support of a research institution or some motivation from top, because without this communication networking, no farmer is going to adopt you in large scale. No, it will stop with only pump, because they cannot afford to spend for the networking. Because if you talk about Ndvi IoT, which you can use for high cameras, everything, it's what about the normal operations? So that has to come, that technology. There are different type of technologies available. I will not cover all of them. I think this is not required. LoRa, what I told you is the, it is one more thing with this spread spectrum technology is a low data volume. Let us say a few bytes goes, maybe you can actually you can put up to hundreds of bytes in a second from each device. But it is very good for noise. It can go through walls. Okay, it's not like other. It's available. It's available for last several years in India itself. There are many companies trying to do it for street lights and all. They're using already. Ndvi IoT is not never started. It will start soon, but it's expensive. It's like SIM card again, so you can use for it. Then satellite also is available now in India, possible to use for satellite. And online, then you come to online to control complete walls of irrigation, depending on the moisture sensor. For example, this from BISA, you measure the moisture, how many kPAs are there for each one of the sensors, how much kPa. Based on that, you trigger the irrigation. And irrigation schedule you must have. So I help them with the wireless connectivity only. Rest of the irrigation scheduling, they already had made. Then you must know about protocols. What protocols? This is a mistake we do. A lot of protocols are available. And you as agriculture guys must tell which protocol. You have to read about it. I will not tell you much about, but you know HTTP. Most of data communication, HTTP, don't accept for agriculture. I think it's difficult. MQTT is an excellent protocol, which are used for the remote devices to connect. Maybe it's about last 10 years. It is stable now. It's used extensively throughout the world. So you have to know a little bit about protocol. I will come back to the last one slide of sustainable IoT solutions to make a lot of field challenges. Okay, it must be rugged and simple. It has to withstand harsh environment. Okay, it's a harsh environment, really outside the field, because it's 24 hours, day and night is there. And rodents, animals are the problem. We take care of it. Theft is another problem, especially with solar panels, whatever it is. Power outages, of course, we all know it. Lightning is the biggest issue. People don't know about lightning. Any wire cable down there, lightning will not damage immediately. It's a silent killer. Slowly, it will react after, let's say, couple of months even, it can extend. So lightning is another one. Networking is an issue, but now technology is available. You have to work on networking technology. Select, for example, BLE, whatever it is, which are low range sensors actuated. For example, if a cow barn or milking barn, you can use a lot of Bluetooth technology, which are cheaper, and then have a gateway which gets you the data outside. So this you have to study. I mean, you don't expect a IT guy will design for you. He does not know the intricacies of agriculture. So you have to know basics. You need not learn electronics to design the systems. That he will do it, but he will know exactly what you're getting it out. Then your poor assets for service in the farm, and return of investment is important in agriculture. Agriculture, if you come to me, for example, there are a lot of discussions on drones. Okay, the question is, forget about whether 5 times more efficient and spraying with a normal pump or with the drones, but think about how are you going to charge me money? Which farmer will pay for some of the important things like locust? We have used it, but practicality, you must know how these persons will use it for at least 78 hours for 3 months at least, because you have to pay salary for the guys, all of them. So any technology to implement, we have to think about what is the returns of investment, how long it will take. Because you start a company, funded company, and make a nice paper will not work out, because it doesn't come out that way. You have to think of farmers must be need the technology. He will get benefit out of the technology. For example, I tell you a lot of examples, like you save water for him and give him, he will buy. 100% he will buy, because how much is, for example, soybean now cutters are very useful because they save a lot of labor costs. 600 rupees they have to pay for cotton pickers per day. So if you can give a machine like that, they would love to have, then have to irrigate you. And we have to know one more thing, irrigated area is also, I mean, rainfed area is significant in India. Rainfed area is very significant in India, and water wastage is too high in irrigated land. So let's all work together. Let's not, 2% of water is only we use for drinking purpose. So we see a lot of TV ads coming here, one drop of water, you close the tap, but it's hardly 2%. And around, if I remember correctly, 12 to 15% is the water we use for industries, rest of them for agriculture. So we sitting at agriculture, we don't want to say that, and we have a lot of conferences, everybody does it, but feel in the level, it's a bit difficult to see even today, because people still go for subsidies in deep water pumping, solar panels and stuff like that. For river water lifting, solar panels excellent, but nothing for deep well boring water. We should try to use our technology pump. That's all. I stop here. I think it was a story to you. Thank you.
Thank you so much, sir. Now we'll have a brief questionnaire session. I'll just read out some questions. So the first question is, what are the best applications of IoT in agriculture?
Okay, the first one I see water. That means you want to drip irrigation, automatic watering. Second application, agriculture, means without IoT, you don't get benefits of protective cultivation. Okay, all the polyhouses, everything, they're very, very useful. And the next one you go is the which is developing area warehousing. Okay, the warehousing is building very fast now, but still it's 4 walls only. Even in Punjab and all recent now they are. But then you need a warehousing, automation warehousing. IoT warehouse is good. Animal is excellent. A lot of NGOs are working on animals also in IoT.
Okay, sir. Next question. Can farmers be guided for irrigation scheduling with the help of AI?
AI is needs a lot of data. Okay, AI has a lot of layers. Those who knows about, see, there's nothing called. I know I'm a old timer. I look at expert systems. You know, AI started in agriculture. It was a case of class combines. CLA is the company name. Class combines. You also have in India. When you visited, they have a problem. They are robots for making the combine harvest for spot welding. So the AI expert system there, it was thought. This I'm talking in 1980s, started from there. So AI doesn't come without layers. AI will be useful, but it will take time for us to get all the information. It will take 4 or 5 years, and we need a fast data collection. So this must be done by government or NGO organization, this data collection. Farmer cannot help.
Okay, sir. Sir, the IoT sensors you talked about earlier, can farmers also install this very easily? And like mostly farmers, they do not have any technological like knowledge and skills to use it. So how will it be beneficial for them?
I think any sensors must be simple enough that farmer must be able to install. Farmer has got a tube light, he has got a bulb, he changes himself. So it should be, the technology must be there, and people know how to use cell phones, mobile phones. Everybody knows. You won't believe it. I think even in go to Gujarat, a farmer uses. He shows me in his cell phone how much his pump consumes current. Okay, he purchased from a pump. So this is very interesting, and he is not well educated, but he says this is the current. So I know whether it is any phase missing, everything. So I think technology is possible.
Okay. So next question. What is acceptance of IoT in present day among the Indian farmers?
It's very less. Penetration is very less. Very less. I told you the pump starter. Okay, that's excellent IoT device working effectively. This year, I think Tamil Nadu government has given 5,000 rupees subsidy for the guy to install the pump starter, automatic pump starter. But one of the laughing by note is for that is because snakes bite the farmer. But actually, it can be improved still further. Not only starting the pump, but can log even how many hours it works. Okay, a lot of stuff, how much water coming, everything can be logged with that. So his approach should be towards the final result, what farmer can get more. He buys one and he gets additional benefits. Till now, it has been in the primitive 10 years done. I think there's a lot of work. Other than that, we have to actually, youngsters have to come and push through and look for, I told you some of the irrigation, automatic control is one of the biggest areas farmers want.
Okay, sir. So since everything has an advantage and a disadvantage, so are there any disadvantages of IoT-based smart farming, smart agriculture?
See, disadvantage, everything they have advantage, disadvantage. I don't agree with the statement first. This is only assumption people make it. Like, I don't like mathematics. Mathematics hard, everybody says. So I don't believe it. But at the same time, I say that drawback IoT doesn't exist. If you don't design properly, yes. Because see, too much of dependency on the networking, data only cannot have. You should have local intelligence also built inside in case the drop of network.
Okay, sir. So that was it for today. Like the questions, those are the questions that I asked. So thank you so much, sir, for this wonderful session. It was an honor to have you again with us. I hope you had a great time, sir. Thank you so much.
Thank you. Thank you.
Thank you everyone for joining today. So this is the end of today's session. You all may leave now.